This is pre-calculus notes on section 6.4, reference angle. 6.4, I'm trying to get it so you can see. The section is 6.4, reference angle. Okay. This lesson is a little bit trickier than some of the previous lessons, and it's really, really important too. So you're going to have to practice this. All right, first of all, definition of a reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. Okay, I'll keep saying that over and over again as we do some problems. Our first problem is a quadrant 1 angle, and here is my example angle in quadrant 1. Okay. And so I've got it drawn here, all right? Here's the initial ray, there's the terminal ray. Here is my theta equals pi over 5. All right, so the definition of a reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. In this particular case, we've got an acute angle in quadrant 1. And so the reference angle equals the original angle. Oops, it's not letting me move it separately. But these two things are equal, okay? They are the same angle. This is not always the case. You're going to see some harder problems, okay? But in this case, the reference angle, which, by the way, is notated by theta prime. Now, the way that you write theta prime is by writing theta and an apostrophe. And the way that we say it is theta prime, okay? So theta prime is the reference angle. That's it. Next problem. So here we've got a quadrant 2 angle. Okay, and here's my angle. Theta is 4 pi over 5, okay? So here is 4 pi over 5. Its terminal side falls in quadrant 2, okay? So, the reference angle is the positive acute angle formed by the terminal side of theta, here's the terminal side of theta, and the x-axis. Now, all of this is the x-axis, okay? But that red part is not acute. And so here I've got a different, smaller angle that is acute. And so this angle in blue is the reference angle, the positive acute angle formed by the terminal side of theta and the x-axis. All right, so how am I going to find the measure of that blue angle? Okay, well, what I'm going to do is I am going to take this half circle, and the measuring radians of a half circle is pi, and I'm going to subtract the red part. Okay, the red part is over here. Oops, let me move my mouse. Over here, okay, that's the red part, 4 pi over 5. So here is my calculations. Okay, I'm going to find blue. So I'm going to have theta prime is equal to pi subtract 4 pi over 5. All right, I need a common denominator. So I'm going to multiply top and bottom by 5. So I have 5 pi over 5 minus 4 pi over 5 equals pi over 5. So theta prime is pi over 5. Next problem. Okay, this one I designed for you guys to try by yourself. It is done exactly the same way as the previous problem. Pause the video, give it a try for yourself. I'll very quickly go over it in just a second. Okay, so my theta prime, again, in this case, is going to be the half circle pi subtract this red part. Okay, so I've got pi subtract 2 pi over 3. Common denominator is going to be 3, so I'm going to multiply top and bottom by 3. So I get 3 pi over 3 minus 2 pi over 3. So theta prime, the reference angle, is pi over 3. Next problem. Here I've got a quadrant 3 angle, okay, and this one is 6 pi over 5, okay, already shown there in red. The reference angle is the positive acute angle formed by the terminal side of theta, which is right here in blue, and the x-axis. So it's this part here. Now, in this case, that blue part is part of the red part. It's a smaller part of the red part. If I were to go back and look at the previous problem, the blue part was external. It was the supplement of 2 pi over 3. So there's not one formula for all of these problems. You really have to visualize them and kind of determine from yourself which angle is formed by the terminal side of theta and the x-axis that's positive and acute, and kind of come up with your own formulas as you go along. Because there's not one particular rule I can give you. So anyway, in this problem, what I want to do is I want to subtract a half circle from the red part to get the blue part. So theta prime is equal to the red part, which is 6 pi over 5, subtract pi. That's a half circle. Again, I need common denominator. So I have 6 pi over 5, subtract 5 pi over 5, which is equal to pi over 5. Okay, now, I gave you some images. I drew the angles for you in the previous problems, but in most cases, you're not going to have that. Nobody's going to tell you which quadrant they lie in or anything, so you're going to have to figure that out yourself. So here I have just an angle, 4 pi over 3, and I need to figure out which quadrant it lies in order to determine how to find the reference angle. So one of the things I want to do, I might consider doing in order to figure that out, is I want to keep in mind that pi is a half circle, and that 2 pi is a whole circle. More importantly than that, or even more extensive than that, I really need for you to memorize or make it intuitive to yourself that these that we start with 0 and we rotate counterclockwise, that this a quarter of a circle would be pi over 2, a half circle is pi, 3/4 of a circle is 3 pi over 2, okay, which is the same as saying 1 1/2 pi, and then a full circle is 2 pi, okay. That just has to be intuitive. I'm sure that it's not just yet, but you've got to practice it enough until it is intuitive. All right, so if I want to, what I might want to do is I might want to think about 4/3 pi as a mixed number. It might kind of help me understand where this falls. So 4 divided by 3 is 1, remainder 1. So saying 4/3 pi is the same as saying 1 1/3 pi. So what that means is it's rotating more than a pi. It's rotating pi plus 1/3 of a pi more, okay? Well, 1/3 of a pi more is less than half a pi more, okay? If it was greater than half a pi more, it would go into quadrant 4. But since it's only a third of a pi, that's less, 1/3 is less than 1/2, it's going to end up in quadrant 3. So there's the 4 pi over 3. The reference angle is right here, formed by the terminal side of theta and the x-axis. And so I'm going to subtract pi, half a circle. I'm going to subtract pi from that. So I've got theta prime equals pi, subtract 4 pi over 3. Oops, I had that backwards. Let me try again. Excuse me. It was actually 4 pi over 3, subtract pi. Okay, so common denominator is 3. I have 4 pi over 3, subtract 3 pi over 3, which is equal to pi over 3. Theta prime is pi over 3. I'm going to do one more. This video is very long. I have lots more examples, but I lose something when the videos become too long. So just one more. All right, so 9 pi over 5. Let me try and put that in terms of a mixed number. So 9 divided by 5 is 1 with a remainder of 4. Okay. So in this case, theta is less than 2 pi. Okay, let me draw this. Okay, so it's more than a whole pi. 4/5 is bigger than 1/2. Okay, so it's going past 1 1/2 pi, but it's not bigger than 2 pi. So it's going to be a fourth quadrant angle. And in this case, the reference angle, theta prime, is between the terminal side of theta and the x-axis right there. And so here, my theta is external. It's outside of what I want theta prime to be. So I'm going to subtract from 2 pi to get that. So theta prime equals 2 pi, subtract 9 pi over 5. Common denominator, I'm going to multiply top and bottom by 5. So I have 10 pi over 5, subtract 9 pi over 5. This is pi over 5. So theta prime is pi over 5. A closing remark. When I originally wrote this lesson, I kind of thought it simplified matters to only use theta prime is pi over 5 or pi over 3. In hindsight, I probably should have used some more varying examples. The procedures are this, you're going to use the same procedures, but your answers are not always going to be pi over 5 or pi over 3. And you'll see that when you get to the bookwork. All right, that's it for that video.